Okay, so section P6 is rational expressions, which basically puts your two least favorite things that you do in math together. You're going to be doing fractions and factoring, but it's really not as bad as you think. So basically, a rational expression is a ratio of two polynomials. So two polynomials written as a fraction. It's rational because one's divided by the other like a ratio. So this little note right here that the polynomial, you're not going to be able to divide by zero. That's a no-no. You can't take something and divide it into no categories. So that's going to cause a domain restriction. So rational functions have a domain restriction. So that's really the first thing that we're going to look at is what values must be excluded from the domain. What is your domain restriction? Looking at some rational expressions. So domain restriction is just what makes the denominator zero. We can't divide by zero. So if this denominator is zero, we have a problem. So to figure out what would make the denominator zero, you just set it equal to zero and solve. So in this case, you would get that x is -5. And so we're finding what must be excluded from the domain. So if it says what must be excluded from the domain, then you can just say x cannot equal 5. If they ask you for the domain, then you would just say all x's such that x is not -5. All right, so number 2. Again, they just want to know what's the domain restriction going to be. And that is found by taking the denominator and figuring out when is it 0. So if we add 36 and then take the square root of both sides, we know the square root of 36 is 6. But if you're the one putting square root in the problem, you're the one that said let's take the square root of both sides, so x is by itself, you have to put plus or minus. So again, all you have to say is that x cannot be plus or minus 6. I don't need you to write it in this fancy way. I was just making sure you had seen that before. Okay, so number 3, we need to know when the denominator is 0, so we know what we cannot have for x. So this guy, we're going to have to factor. So we'll have x and x, and we'll have a 7 and a 2, let's say a -7 and a +2, because that would give me +2, -7, that's my -5. So then they have you do this in this section, but they don't actually teach you about solving quadratics and stuff until later chapters. So just a quick reminder, you have two things being multiplied. So the zero product property says this could be 0 or this could be 0. Both of those are going to happen at some point with this function. So you're going to end up with two separate answers. So we cannot have 7 and we cannot have -2. All right, so the first section of your assignment, that's all it's asking, is about those domain restrictions. What values are going to cause us to divide by 0 and give us trouble. For the rest of the problems, I think it says in the directions to find those excluded values. I don't need you to do that. I just need you to do the simplify, add, subtract, multiply. Just on the first section do you have to do this part right here. All right, so the other thing that we're going to do today is can we simplify and can we multiply and divide rational expressions? So first of all, y'all need to make sure you understand that when you're simplifying, that means that you are going to divide off any factors that they have in common and then just write down what you have left. Now, before you can divide off factors, you have to factor and know what the factors are. So if you look at this problem number 4, I cannot just say this x can divide into those x's. Because of this plus sign, it gets your order of operations all out of whack. Order of operations says I have to combine these before I can divide by something. So if I can break it down to where I have something times something over something times something, then I can always divide off factors that numbers have in common. Just like if I had a 24 over a 36, we know that 24 is 2 times 12, and we know 36 is 3 times 12. So we can divide off that common factor of 12 to reduce our fraction to 2/3. We're doing that today, but with uglier things, with polynomials. All right. So very important that you understand that you must factor the numerator and denominator completely. Then you can divide off common factors. All right, so number 4. Step 1, when you're told to simplify and you have a big ugly fraction, a rational expression, you're going to factor the numerator, factor the denominator. Sometimes both will factor, sometimes only one or the other will factor, sometimes nothing's going to factor. All right, so looking at the numerator, I believe we can take out a GCF of x squared and have x plus 3. The denominator, this x plus 3, that's not going to factor, but we can take the entire denominator and divide off that numerator factor that matches it. So this and this can divide equal 1, and we just have x squared as the simplified form. All right, so number 5, if we take x squared minus 1 and we factor, that's a difference of perfect squares. So it'll be x plus 1, x minus 1. On the denominator, it's a trinomial, so we're going to try to get 2 little binomials. We have x and x. We have 1 times 1. Everything's positive, so everything's positive. This is going to work because that's 1x and 1x, which gives me 2x. So we are done factoring. All of the factoring in this section is going to be like the simple factoring that you like. It's not going to be the crazy stuff like we did in day 2 of section P5. All right, so looking at what we have here, we are going to cancel or divide off x plus 1. Now make sure that you understand that this can only divide one other one. It cannot divide extra ones. We can't knock this one off because there's not one to go with it. So you can only do a 1 for 1. So that leaves us with an answer of, we don't need the parentheses, x minus 1 over x plus 1. All right, so people get caught up in let me cancel and they want to like say cross out these x's, cross out these 1s. You cannot cross out part of an addition subtraction statement. These guys are tied together. You cannot take one without the other. The same thing here. Okay, and since these don't match plus minus wise, you're just done at this point. All right, so that's basic simplifying. Now we want to talk about multiplying and dividing, which is just simplifying but with more pieces. All right, so multiplying and dividing, you're going to factor all of the pieces, so all of the numerators and denominators, divide out common factors, and make sure that you always cancel things out with a numerator and denominator. You have to have a top and a bottom that match. You can't cancel 2 bottoms that match. And then multiply your remaining pieces, making sure that you multiply like you're supposed to with fractions, top comes top, bottom comes bottom. And then this is very important. People sometimes forget. Remember that if it says divide, you're really multiplying by the reciprocal. So keep, change, flip. You're going to change it to multiply and flip that second fraction. All right, so number 6. X plus 3 will not factor, so just write it down. X squared minus 4 is a difference of squares, so it factors to x plus 2, x minus 2. We have x squared minus x minus 6. That's a trinomial, so we're going to try to get 2 binomials. We know we need an x and an x. Probably a 3 and a 2. We want a negative in the middle, so negative 3, positive 2. For this guy, again, it's a trinomial, so we need 2 little binomials. We want an x and an x, and probably a plus 3 plus 3. All right, so now that everything is factored, then anything that matches from a top to a bottom, it doesn't have to be from the same fraction. It can be crisscross. It just has to be any top with any bottom that matches. So we can say that this cancels this. We can say that this cancels this. And looking at what we have left, there's nothing here, not really nothing, there's like an understood 1 here, times x minus 3. And in the denominator, we have x minus 2 and x plus 3. And I'm okay if you leave it as factors. You don't have to multiply it out. So I'm good if you give me this as your answer. And again, these are not going to cancel because one's plus and one's minus. Okay? And you can't cancel pieces when there's addition and subtraction. Only when it's multiplication can you cancel things. Okay, so number 7, we are dividing. So what that means is we have to multiply by the reciprocal. So when I'm doing my own work, I don't actually write this down. I just factor and do multiply by the reciprocal all at the same time. But I don't want to skip too many steps just to make sure that you're on board. So step 1 is change it to multiply by the reciprocal. All right, now we can factor. So this numerator, we can do x plus 1, x minus 2. No, we can't. Oh, I'm multiplying to get a 1. Sorry, I was completely looking at the wrong thing. Let me back up. I think it's going to be x minus 1, x minus 1. Yes, that works. All right, the denominator, I can take out an x. And that leaves me with x squared plus 1. All right, for the next numerator, we can have a GCF of 3, which leaves me with x squared plus 1. And then the denominator, we're going to do x and x. And I think plus 2 minus 1 is going to work out. All right, so now you're at the what can I divide off? What factors will cancel each other out? That's not really a math term, canceling, by the way, but y'all understand it. Okay, so we can take an x minus 1 for an x minus 1. And we can take an x squared plus 1 for an x squared plus 1. And I believe that's all. So in the numerator, we have an x minus 1 and a 3. We like to put the single numbers in front, but it's multiplication. It can happen either way. And the denominator, we have an x and an x plus 2. And we are finished. All right. I want to say that's all the examples that I have. Let me check. Yep. Okay, so like always, if you have a question, send me an email. If you get to working and you get to one that you're not sure how to do, you're welcome to email me and I'll work it for you and send it back to you.